Hey everyone, welcome to Unit 4, Section 2, Properties of Metals. We're going to talk about how we use those crystal structures to use some of our most basic physical properties of metals. So, just a quick review. What are the properties of metals? Well, or what are properties to begin with? Properties, characteristics used to identify a metal, a material. We've talked about chemical properties. These are how material interacts with other materials, other matters. This is reaction itself. We've talked about things like acid base, that sort of thing. More particularly in terms of metal, we're going to spend a lot of time on this next unit with corrosion or rust and how that works there. How do metals become ceramics? Those are some big things. Physical properties, these are the properties that you can look at by itself without doing interactions with any other material. We have talked about melting points, right? Color, solubility, crystal structure is another one. All of these fall under, there it goes, the physical properties, okay? In terms of physical properties for metal, that's what we're going to spend a lot more time on, okay? Properties of metals are really unique compared to your other materials, so polymer and ceramics and glass, and that's because of their sea of electrons. We've talked about this a couple times, you guys. You really should know this. Sea of electrons is that equal sharing of these electrons that allow us to go all over the place. Let me find a pen. So all of these electrons, they can move around here and go around back there, this way, and do that. Why is this important? Well, because it allows these guys to move wherever they would like. Go there, it can go there. Because they have the sea of electrons, it does not take very much energy for those bonds to break. Whoop. There we go. Not a lot of energy. You've seen this animation before. You've seen it a couple times, guys. I want you to pay attention to how this guy moves and then this one moves. They do not all have to break at the same time. If we had to draw a line right here where they would all have to shift, that would require a lot of energy. A lot of you missed this question on the NOVA worksheet because you said, yes, it requires a lot of energy. No, it doesn't. That's why we can bend metal with our hands, but we can't bend chalk. When we try and bend chalk, chalk breaks. It's that ceramic, it breaks, right? Because everything moves at one time. Okay? So what are some properties of metals that we should be familiar with? One of them, good conductors of electricity. Okay? That sea of electrons here in your battery means because they can move so easily and everything's so shared, they can move around your circuit without any problems. So those free electrons, once we get them, if we get them moving in the right direction, that's how we get that flow of electricity. Okay? They go because they flow from one area to another. Another one, good conductors of heat. Again, it has to do with that flow of electrons. Because those metals can move so easily, they can bump into their neighbor, which bumps into their other neighbor and causes that movement. Remember, heat's an increase in movement. The heat from this end to transfer easily to its neighbor. Okay. What are our other good ones? Luster. Now, luster is the ability to reflect light from within, and this is, let me show you what's happening here. I'll erase that so I can restart. What's happening is that when light enters an atom, it causes that atom to become excited. So or electron. Here's an electron. The energy from the light hits it, and it steps up to a new energy level. Okay? Now, a lot of things just absorb that, okay? If in a regular material, that energy comes in, reflects off, and comes back out. That's regular reflection. But with these guys, what then happens is that electron will then fall back down to its original energy state, lose that energy, and then their energy is released again. So that reflection coming in, it's not just a reflection of light from out here, but from within the atoms itself, which gives it that luster, that shininess. It's not just a reflection like this. This would be a reflection, but it's the light coming from within, like right here. Okay, this would be pure reflection. The luster, though, that shows us that that's a metal, that's from within. Our other very important ones, which we're going to spend some time on with your labs this week, okay, is the metals are ductile and malleable. Okay, ductile, ability to roll into wires, malleable, ability to be rolled into sheets. Now I'm going to move these guys one at a time, just because it's the easiest way to do it. But remember, any of these single atoms can move any way they want at any time. Okay, so as we apply pressure to those metal atoms, and as they break bonds and move, they can shift slowly from one place to another. All right, but as they shift, what eventually happens is that they can shift into different shapes. Now they will still have eventually their same structure. See, it's not changing at all, but it will be in a different arrangement. So you have your crystals being here, same crystal structure, it's just rearranged so that it's flatter and thinner. Okay, just like us changing desks in a classroom. Still the same number of desks, still the same number of kids, just a different arrangement. Okay, same thing with ductility. This would be your example of what happens to a wire as it's being pulled through a wire form. Okay, and so we have the same amount of atoms here as here, but the space is much wider. Okay. So you're going to try a lab with that one. Just show that we still have the same number of atoms, and it's still in the same space arrangement, so the crystal structure is still the same. It's just now we have more area than we did before. Okay? More area, less thickness, right? So our volume should still be the same. Density should still be the same. Those are big questions that are important on your lab. Okay? Let's go ahead and finish it up. What do we do about changing properties of metal? How do we do this? Because this is what we're going to step into that next section. Okay, first of all, you can use a different metal. For example, copper versus brass. Different metal. Okay? How does steel differ from titanium? We choose a metal based on what its properties are. So, looking at that. Biggest thing, this is where our next unit comes into play. We can add different stuff to it. In other words, we can create an alloy. That can be an alloy like brass, where you're using two metals, nickel and copper, to make a mixture, or it could be like steel, where you're using a metal and a non-metal, iron and carbon, to make your metal, to make your material. And remember, steel, you have all those different ones. You have martensite. Whoop. Let me go back here. You've got all those other ones. You've got martensite. You have austenite. You have cementite. They're all steels. They just have different amounts of carbon and structure to them. Okay. One we are very familiar with, how do you change a property? Why do we change properties? Well, we can heat treat. Okay. Change our size or shape. So we can anneal, quench, or temper. And we've learned how those things have different properties. Annealing makes metal softer, quenching makes it harder but brittle, tempering takes some of that brittleness out of that quenched steel. So those are all things that we can do. Depending on what we quench in or temper in, again, will change our properties. Okay. The last way we can change the properties of metal is to disrupt that crystal structure. In other words, work harden. Okay. This is what we did with our copper wire activity. Remember, we made that metal a lot harder to work with this time. Okay, so guys, that's it for now on the properties of metals. You are going to go ahead and start labs for brassing, rolling of a penny and stuff, so we can take a look and see how, even though you're changing the structure of the metal, you're actually not changing its density or volume at all. So take a quick peek at the next video to see how to do those two things. All right.